So today's professional learning is on fluency and error analysis. So error analysis is situated in our instructional platform within explicit instruction and within fluency. So what is error analysis? Error analysis includes determining what errors students are making, why they are making those errors, and what we can do to remedy them moving forward. Error analysis informs our instruction, and most importantly, within Spiral, we want to think about how error analysis can determine next steps for supporting individual students. So today we're going to talk about two different types of error analysis. The first type is analyzing work samples, and the second type is conducting diagnostic observations or interviews. So we'll start with analyzing work samples. When you're analyzing work samples, you might notice something called slips and something called bugs. Slips are errors that are not indicative of misconceptions. Sometimes we call those silly mistakes. Just students aren't thinking, they make an error that is not indicative of a lack of understanding, just a silly mistake. And these can often be remedied with better organization or self-monitoring skills. But what we want to pay even closer attention to is bugs. And bugs are errors that are indicative of misconceptions. And those are errors that we need to provide intervention related to. And in order to identify bugs, we want to look for error patterns. So let's go ahead and try our hand at this. So here we have work examples from one student. So I want you to take a moment to review these computation examples and try to determine, did this student make a slip or do they have a bug? As you're observing and as you're thinking, let's notice that on the left side, we have 2-digit by 2-digit addition that has been solved correctly. 34 plus 69 has been solved correctly. 606 plus 98 has been solved correctly. But we have an error on that right-hand side, and I'm seeing 3 folks have gone on in the chat and said a slip. I would agree. And so what is this slip? What specific error has this student made? Go ahead and share in the chat. Place value not aligned, absolutely. And we know that it's not a misconception because 3 times over with 2-digit and 3-digit numbers, they've solved those problems correctly. And so this is most likely just a slip. This student needs help ensuring that they align the place value positions correctly. So what can we do to support this student? Maybe we'll just teach them to carefully line up the numbers by place value and draw a line to separate the columns. So this is a self-monitoring strategy. This is an organization strategy so that hopefully moving forward, this student will be less likely to make this same error. All right, let's look at a different set of computation examples. What do we notice here? And does this look like a slip or a bug? So I see that one person, 2 people have said bug. So what is this error? What is this bug? What mistake has this student made? What misconception do we think they have? Okay, no concept of regrouping, absolutely. So if you noticed, on the left-hand side, instead of solving 800 minus 692, they've actually ended up solving 892 minus 600. So instead of regrouping, they've swapped the digits from the minuend to the subtrahend to make subtraction easier in their mind, but in reality, they've solved a completely different equation. And so, what can we do to support this student? Maybe we can teach them through explicit instruction that digits are not interchangeable when we subtract. What can we do specifically, though, to help remedy this misconception? In the chat, go ahead and share. How might you clarify and reteach regrouping for this student? I know that for me, the first thing that I would do is grab some base 10 blocks. Exactly what just popped into the chat. Absolutely. You might grab some base 10 blocks and really show your students with concrete manipulatives how to regroup 100 into 10 tens, how to regroup 110 into 10 ones, and demonstrate for them that they have solved a completely different equation. Excellent. All right, let's look at one more set of computation errors. What do we notice here? And there's a lot going on, so I'm going to give you a little bit of time here. I'll go ahead and voice over. So here we see 5 times 2 has been solved correctly. 4 times 3 has been solved correctly. 80 times 3 has been solved correctly. But then when we introduce 2-digit by 2-digit multiplication, this student's computation proficiency completely breaks down. And so this set of examples is to illustrate that sometimes error analysis can be messy. There's not always one specific bug, specific slip that you can identify. Sometimes through error analysis, you identify that a student needs explicit instruction on a skill. And in this scenario, this student needs explicit instruction on how to multiply 2-digit numbers by 2-digit numbers. So one tool that you have in your spiral notebooks are addition and subtraction, whole number, computation intervention trackers, as well as what you see a snapshot from here, a multiplication and division intervention tracker version. And so I will actually be talking with y'all more about this towards the end of today's professional learning. But here I just want to show you that within this tracker, we can check off that this student has proficiency with multiplying 1-digit by 1-digit numbers. We can check off that this student has proficiency multiplying 1-digit numbers by 2-digit numbers. But where the student needs instruction and intervention at is with multiplying 2-digit numbers by 2-digit numbers. All right, so now go ahead and grab the examples that you have gathered of your students' computation errors. I'm going to split you into breakout rooms, and I want you to look over those computation examples and identify examples of slips and bugs. Remember that slips are those silly errors, those silly mistakes that students make oftentimes without thinking. Bugs are when we see a pattern of errors that are indicative of misconception. So now we're going to transition into the portion on diagnostic observations and interviews. So diagnostic observations and interviews can provide a clearer picture of students' thinking. So maybe when you're analyzing a student's work samples and you're not really sure where to start or what the problem is, that might be a good opportunity to begin a diagnostic observation or interview to provide a clearer picture of their thinking. This can serve as an opportunity for gathering information, not necessarily an opportunity to provide instruction. So some quick tips. You want to make sure to accept students' responses without judgment. That way, the next time that you discuss their work with them, they won't have their guard up. They'll be willing to respond and share their thinking. In that same line, you want to make sure to keep your responses neutral And you want to ask probing questions, not just about their incorrect answers, but also about their correct answers. Because when we only question students about their incorrect answers, they can begin to have this aversion to having questions asked because they assume that when they're asked a question, that means that they made an error. So we want to kind of spread out our questions so that they have opportunities to explain their thinking with correctly solved problems as well as incorrectly solved problems. So, when you're conducting an interview, you might use a simple script. And I got this simple script from the book that you see in the corner, Error Patterns in Computation. And on the website, I also have a PDF version of this script that I'll email you at the end of this week as well. So, you might start by saying, "Read the problem, please. What is the question asking you to do? How are you going to find the answer? Do the work and tell me about your thinking as you do the work." So, diagnostic interviews can be very simple, and you can use the same language throughout all of them. And then finally, write down your answer. Or you might ask, "How did you get your answer? I may have missed something." You might say, "If you had to teach someone else to solve this problem, what would you tell them?" That's a really great way for students to be super descriptive in explaining their thinking. And then this is my favorite. You say, "This time I'll hold the pencil. You act as the teacher and tell me what to do." And so you grab the pencil, and with the problem in front of you, the student will tell you everything. So they're going to tell you every number before you write it. They're going to tell you to write the plus sign before you write it. And that really is going to break down their thinking incrementally for you. So this is just a few examples for how you might conduct some diagnostic observations or interviews as a method of error analysis. Now, while you're gathering all of this data, you want to make sure to document it and, most importantly, transform it into next steps for instruction. We want to make sure that as we're gathering all of this information about what errors our students are making, we are then turning around and attending to them and providing intervention that is tailored to our students' needs. So, what do we do with this information? How do we address these errors? Well, if you notice that students are making slips, you might teach students to organize their work, write neatly, and check for mistakes. And in order to do this more reliably, you might introduce self-monitoring checklists. So here's an example from that same book from before. So students have to fill out this checklist to turn in with all of their assignments. So they mark off yes or no. My digits are written in place value columns. Others can read my numerals. And then some reflection questions. Sometimes I was stuck. I checked my answers. Describe a situation in which this computation could be used. This is an example of a self-monitoring checklist that I created for my second graders when we were using the base 10 block pictorial method for computation. And so what you can do is, if you notice a lot of similar slips that a lot of your students are making, you can design your own simple self-monitoring checklist that has all of those common slips on it. And that's what I did here. So numbers are represented correctly. Are the ones and tens organized into 10 frames? Is my answer clearly written, etc.? Now, bugs are where we want to put the most of our energy into. When we talk about bugs, we're talking about misconceptions. We want to address these with step-by-step modeling, guided practice, and timely feedback. We want to make sure that we're using a ton of hands-on manipulatives as well as visuals. And we want to introduce brief daily fluency practice once students are proficient with the skill that we have just intervened on.
All right. Thank you so much, Allie. Hi, all. My name is Sarah. I get to be your guide for this next part focused on fact fluency. It's one of my favorite things to think about, and maybe it's one of your favorite things to think about as well. So we are going to think about where does fluency fit into our instructional platform? Well, throughout Spiral, we've been talking about these components that are important for mathematics instruction. Those components have been explicit instruction, vocabulary, multiple representations, and look at it, fluency, there it is, as well as problem solving. So let's spend a little bit of time on fluency, but we can't talk about fluency without thinking about how do we explicitly teach ideas related to fluency, what's the vocabulary that's important for fluency, what are the representations that we want to bring in to help students with their fluency skill as well. And then I know that all of you are very aware that when students have fluency in mathematics, it's going to help with their problem solving. So many times these components of this instructional platform are interconnected. So I mentioned earlier about how fluency might be important for word problem solving. And let's look at three examples where if students had some fluency with their operational skill, they may have been better at setting up and solving these word problems. So look here at this word problem. And in this word problem, the student, there's some pens, and then they broke some, and now they only have six. And the question is, how many pens did this student have to start with? So, what's really great about this student's work sample, and these are all students that go to school in Austin ISD, but what's really great about their work sample is that they figured out, well, if I add 19 and 6, that would tell me how many pens David had to start with. But then look at their work. So this gets into what Ali was talking about with an error analysis. What did this student do to answer this problem of 19 plus 6? If you see an error pattern or if you see what the student did, go ahead and drop it in the chat. What do you think the student did to solve this problem? And they didn't solve it correctly. So I'll go ahead and give that one away. Messed up on the place value, right? So here I see what this student did is they didn't line up the values correctly, and then they added the 1 plus 6, and then they added the 9 when we really should have added 9 plus 6 and then 1. Yeah, so by just doing that, then the student doesn't answer the word problem correctly. And when I look at these work samples, it just really hurts my heart quite a bit because I'm like, oh, they were so close. They knew what they needed to do to answer the question, but then they got tricked up by that computation. Here's another example here. There's 46 children at the movie theater, then some children left, and now there's 29 children. How many children left to buy popcorn? So look at this student's work sample, and then in the chat, tell us what this student did to arrive at an incorrect response. Yeah, so I see the chat like they didn't regroup correctly. Yeah, we've got an interesting regrouping there. Yep, that's exactly right. Several of you are seeing that. So if the student would have regrouped correctly, they may have then in the 10 subtracted 3 minus 2 to get to a correct response. But we see that they again, they know the correct numbers. So it's like, oh, and they understand what they need to do to answer that question about how many children left to buy popcorn, but we're so close, yet we're so far. And then finally, here's another one about Lucas, who won 16 blue ribbons, and Meg won 9. And then how many more ribbons did Lucas win than Meg? What did this student do to solve this problem? They've used the right numbers, but what did they do? Yeah, so we've got some hypotheses coming in the chat. They may have counted up and did it incorrectly. They didn't subtract correctly. Yeah, they're really close, right? So if I was subtracting 16 minus 9, I would be looking for a difference of 7. The student wrote 8. So they probably have made some counting error there, but they've got the right numbers. They're understanding that, oh, if I want to compare 16 and 9, I can subtract. So we're really doing really well on what the word problem is asking us to figure out. But then we have an error with our, in this case, our fact fluency. In some of the other cases, we saw errors with our computation. And that is what we will talk about now, because if a student had had some fact fluency here to solve a problem such as 16 minus 9 equals 7, we feel that they probably would have answered this word problem correctly. And that was the barrier for students being successful with this word problem. Now, that's not always the case in word problem land. There are a lot of times the barrier is reading the word problem or understanding what you need to do from the word problem. But here, the barrier is something that we can work on, and that's what we will focus on in Spiral today. So, when we think about fluency, often our conversations in fluency go to the operations of adding, subtracting, multiplying, and dividing. But there is fluency a lot of other places in mathematics, but today we'll mostly talk about these four operations here. And when I say that word fluency, probably all of you have a slightly different idea of what I'm trying to say. So in Spiral, we really think that fluency is doing math easily and accurately. So, how easily can I do a problem such as 16 minus 9? And then, how accurately can I answer a problem such as 16 minus 9? And then when students have that mathematics fluency, it makes things that they do in math easier. Not only does it make math easier for word problem solving, but it might make tasks related to geometry or measurement or data analysis that much easier. And so fluency is going to help students not just with the math, but it's also going to provide less stress on working memory, and it's also going to build confidence. So there's a lot of really good ideas around fluency that we want to capitalize on in Spiral. But as we also think about fluency, we want to make sure that when we're thinking about fluency building in the classroom, that we're not just focused on procedural fluency. So, how do I add these numbers or how do I subtract these numbers? But we also really want to emphasize what the mathematics means. And so that's where those concepts come into play. So, we will always emphasize that fluency is not just a procedural task, but fluency is a meaningful combination of concepts and procedures. So when we start thinking about building fluency conversations with students related to the operations, we first want to build fluency with the math facts. Of the addition math facts, there are 100 of them. 5 plus 8 is one example. There are 100 subtraction single digit facts, such as 9 minus 4 or 13 minus 8. There are 100 multiplication facts, such as 6 times 7 or 3 times 3. And then there are 90 division facts. One example might be 56 divided by 8. So, if you added all those up, across all of our single digit facts, there are 390 math facts where we ask students to have fluency. I don't know if that number overwhelms you. It sure overwhelms me because students have to learn these facts pretty quickly. The typical expectation here in Texas is that students know all 200 of those addition and subtraction facts by the end of second grade. And we ask that students know all 190 of those multiplication and division facts by the end of fourth grade. That's a lot of information to learn in a very short amount of time. And as you all know, fact fluency is only a very small part of what students are doing in math. They're also doing everything related to computation, stuff related to fractions, things related to measurements, things related to geometry. And so we can't just do this every day. If we could, we'd probably know all 390 of those facts, but we have to build in time to focus on those facts throughout the school day. Then that fact knowledge is important for computation. Computation is when we do math problems in steps. So often we think about these with multi digit numbers. And so students have to build fluency with multi digit whole number computation to be able to solve problems like these. And this is where I would not think about a fluency definition that revolves around memorization, but this is where I really like that fluency definition of ease and accuracy. So, can I easily add 15 plus 28 to get to an accurate sum? Can I easily divide 7,250 by 15 to get to an accurate quotient? So that's where we want students to have that ease and accuracy. And fact fluency, which we talked about before, will be really important for this whole number computational fluency. But then our fluency conversations don't stop there. We can move on to fraction fluency, decimal fluency, later in the middle school grades, integer fluency. So, fluency for students really never stops in mathematics, it's all around us. And so, just as a reminder, fluency is doing that math easily and accurately, and it's emphasizing those concepts as well as those procedures. So, in Spiral, as you think about ways to build fluency with your students, I'd like you to think about, well, what kind of fluency are you going to focus on? Is it addition, subtraction, multiplication, and division? Is it two of those or is it all four of those? And you really want to build fluency that's important for students to build. Some students already have a lot of fluency in addition, so do they need to practice that all the time? Probably not, but maybe students need more work with multiplication fluency. So you want to spend time where students need to build that skill. But the nice thing about fluency, particularly fact fluency and computational fluency, is that when we are at the place where students are practicing and developing that fluency, so they have some initial understanding, and now we're trying to really make sure that skill becomes strong, our fluency practice doesn't have to be that long. We can do brief fluency practice with students, particularly on the facts, but that fluency practice does have to occur daily. So I can't just practice fluency on Friday and hope that things are going to stick. We have to practice it Monday and Tuesday and Wednesday and Thursday and Friday, but just a few minutes each day will help students build that fluency practice. And then another thing I'd like you to think about fluency practice is being really mindful with our fluency practice. And by this, I want you to think about, well, what fluency practice do students need? So, one of the first ideas about mindful practice is practice facts that students need to learn. So there are 100 multiplication facts, but I'm going to guess that a lot of your students know what happens when you multiply by zero. Do you know that the answer is 19 of the 100 multiplication facts? So you probably don't need to practice those that much. I would also guess that a lot of your students know what happens when you multiply by one. So that's either times one or one times a number. That answers also 19 of those facts. So you don't have to practice those as much. But I would guess that your students do struggle with 8 times 7 or 6 times 4 or 5 times 8. Those are probably the facts that you need to practice more. So really think about what facts do your students know and what facts do your students have struggle with or have trouble with, and those should be the facts that students need to learn. The next thing about mindful practice is practice in small sets. So there's some research here about what does meaningful practice look like in terms of fact fluency. And they will say practice a small set of facts, maybe 10, 12, 15 facts at a time, but keep practicing those same facts. So maybe you have 10 facts on flashcards and you're going to practice that set of 10 cards. And it's even better when in that set of 10 cards, if some of the facts are already known by the student, so maybe four of the facts are known and students have some pretty good fluency with those facts. And then maybe the other six facts are unknown. Those are the facts, those targeted facts that you want your students to learn. That show when you do practice like that, then students learn those six unknown facts pretty quickly, and then those can transition to known facts, where then you can bring unknown facts into the next flashcard stack to work through those. And then another idea about mindful practice is to practice facts in different ways. And I'm hopeful you'll talk about some of this in your breakout rooms. But you can use flashcards, you can use worksheets. Those are fine ways to practice. But you could also use dominoes, you can use wrap ups, you can have students roll dice and multiply those numbers together. There are lots of games and lots of activities where students are fact practicing, but they probably don't even realize that they're practicing their facts. And so think about mindful practice that is more game like and more activity driven so that students are really engaged in that fact practice. So just some food for thought. I did see a comment come into the chat that says, I still need to practice 7 times 8. I saw a thing recently where that 7 times 8 and 8 times 7 are typically the most difficult multiplication facts that students have trouble with. So I know as adults, we still need some help there as well. Now it's time to get out that spiral notebook. Allie said to grab it. I hope you have it near. So in tab 5, which is our whole focus on fluency, there are some math fact fluency activities that you can go through there. There are quite a few here. And for each of those activities, there is a corresponding spiral video that you can find on mathspiral.com to talk you through that fact fluency activity. You can see right here some of my favorites playing bingo. That's a great way to practice fact fluency. Beach ball math is really fun. Get one of those balls, write some numbers on it, and you can, add, subtract, multiply, or divide with your beach ball, depending upon the numbers that you've written on your beach ball. And there's a lot of other activities as well, like magic squares and cover, copy, compare, and using dice, like I talked about. So I hope you can access some of those fluency activities and talk about those with your spiral coach. And then another thing that you might be interested, I'm going to play this video right here with my amazing colleague Kate, is, well, how do you meaningfully use flashcards to help students build fact fluency? So let's see what Kate says, and you can also watch this video on the Math Spiral website. But let's see what Kate says about using flashcards and how we can use those flashcards in a meaningful way.
Hi everybody, my name is Kate Berry from the University of Texas at Austin, and welcome to this spiral video where we will talk about flashcards with graphing, which is one of our favorite fluency activities. Before we take a look at flashcards with graphing, let's talk about fluency. Fluency just means that we're doing math in a way that's accurate and efficient. And the reason why fluency is so important is it provides less stress on students' working memory, it builds students' confidence, and really it's going to make every other part of math easier. So when we're thinking about fluency, the reason why activities such as this flashcard with graphing is so great is because it's quick and it's easy. And when we're thinking about fluency, we're thinking about something that's brief, so 1 to 2 minutes and daily. So here's an example of our flashcard graph that we have here. You can choose to use addition and subtraction facts or multiplication and division facts, as you see here. We also have our timer and a little colored pencil. You can use a crayon or just a regular pencil, but we'll use that to shade our graph. In this activity, we like to do 2 1-minute trials. You can do 2 2-minute trials if you choose. But based on the skill with which your students are working, either addition and subtraction flashcards or multiplication and division flashcards. So this is an individualized activity, so the student will answer as many flashcards as he or she can in 1 or 2 minutes, depending on how long your trial is. And what's really important about this 1 to 2 minutes is we want to separate the correctly answered cards in one pile and the incorrectly answered cards in a second pile. And this is important because we don't want students just continuing to answer the problem incorrectly. After that first trial, we want to review the problems that the student answered incorrectly, develop some strategies so that they don't make a mistake the second time. Then we like to shuffle the flashcards, do a second 1 or 2 minute trial with the exact same cards, and then the student counts to determine his or her high score. And then you can see here that whatever day we graph the student's high score on our graph here. And it's amazing to see, especially at 4th and 5th grade when students are really competitive with themselves and with each other, how pairing a goal-setting activity like this graph with our flashcards, it really helps develop students' fluency skills. So this is just a quick 2 to 3 minute activity that you can incorporate into your math lesson. So again, all you're going to need is your flashcards, a timer, your colored pencil, and you can even use graph paper if you don't have a fancy flashcard graph like this one. Thank you so much for taking this opportunity to view this video where we talked about a fluency activity called Math Fact Flashcards with Graphing. We hope you'll take an opportunity to view our other spiral videos where we feature additional fluency activities.
All right. So that was a helpful explanation from Kate about how to use those flashcards, particularly with that graphing. She really emphasized how important that is. So it is your opportunity to think about these fluency activities. You might think about fact fluency or the computational fluency. All right. It's really up to you as to where you want to go with this. But in your breakout room, you are going to talk about what are your go to fact fluency activities. So I'm going to go ahead and open those up, and we will see you in just a few minutes. So now after fact fluency, or maybe some of you already started talking about computational fluency, I'd like you to think about, well, what are some of the ways that we can support students with their computational fluency? So there are a lot of different ways that we can ask students to add multi-digit whole numbers, and many of these ways also apply for multi-digit rational numbers. So we have the traditional algorithm when we think about adding these numbers together. We could also use the partial sums algorithm, or we could use place value disks, a representation to help students understand what it means to add. But one of the strategies we'd like to focus on here in Spiral today is the partial sums strategy. So with the partial sums strategy, we are going to add from the greatest place value to the least place value. So to do this, I'm first going to draw vertical lines in there to separate my place value columns. And then starting in that greatest place value, I will add the numbers in the hundreds column. So here as I interpret this, I'm going to add 2 plus nothing, but it's not really 2, is it? It's 200. So if I have 200 plus nothing or 0, that's 200. And then I add the numbers in the tens column. There it's 3 plus 1, but I should interpret that as 30 plus 10, which is 40. And then I add my ones column, which is 7 plus 8, which is 15. Now I can also show this with my base 10 blocks, as you see the visual is set up there. And then I add those partial sums together to come up with a total sum of, in this case, 255. So I can use just the abstract form of the math, or I could use those representations to help support this learning of the partial sum strategy. So on your printable for today, you have a problem. It is 483 plus 95. What would it look like to help your students add these two numbers together using the partial sums strategy? I'd like you to take 60 seconds and give that one a try. All right. Some of you are probably using just the abstract numbers. That's totally cool. Some of you are probably doing some drawings. Maybe some of you have your manipulatives nearby, or maybe some of you are using those virtual manipulatives. So lots of different ways that we can emphasize this partial sum strategy to help students know what it means to add these numbers together. All right, so if I'm looking at this here, there we go. Maybe you did something like my work here. So my partial sums were 400, 170, and 8. So that gives me a total sum of 578. Now, I would like you to tell us in the chat, well, if I'm adding partial sums or if I'm teaching students about adding partial sums, how do you feel about it? Give us a 1 in the chat if you need more practice. Give us a 2 in the chat if you're feeling pretty good. And give us a 3 in the chat if you are feeling great. We'd love to see lots of threes, but I know that sometimes there's always ones and twos, and that's going to be helpful for us and for your spiral coach. Now, when it comes to computational skill with subtraction, there's a lot of different ways that we could subtract. In Spiral, we'll talk about using the traditional or standard algorithm. You can see an example of that outlined in purple. We can also think about using the partial differences strategy, or we can think about this adding up strategy, which is the one we will focus on right now. So when I use adding up, I'm capitalizing on my addition knowledge to help me solve a subtraction problem. And you probably have had the same experience, but pretty much every student that I've ever met in schools, especially in grades 4 and 5, is much better with addition than they are with subtraction. So if that's the case, let's capitalize on that addition knowledge to help us solve subtraction problems. So how can we add up with subtraction? Well, first I'm going to think about the subtrahend. In this problem, the subtrahend is 49. And then I'm going to use friendly numbers for me. So my friendly numbers might be different from your friendly numbers to then add up to 352. Well, I don't know how many I add to 49 to get to 352, but let's work our way up there. So if I add 1, that gets me to 50. And if I add another 50, that gets me to 100. Now, if I add 200, I'm now at 300. Oh, we're getting much closer. So now I could ask, well, now if I add 52, I could get to 352. If we add those numbers in green, that's the difference between 49 and 352. That gives us a sum of 303, which tells us that that's the difference between 352 and 49. The difference is 303. So I'd like you to practice this strategy right now. You've got a problem on your principal. It's number 2, 311 minus 62. How could you teach students to add up using the adding up strategy so that they can easily solve this subtraction problem? I'll give 60 seconds again to give us a try on that one, and then we'll see how you're feeling about it. As you are working, probably some of you are drawing this problem on a number line. That is a great way to solve these problems where I'm thinking about the difference between two numbers. So having students really comfortable with an open number line would allow you to use the number line for problems such as this. So if you had solved this problem, maybe you did some work like this to figure out that the difference between 62 and 311 is 249. So tell us how you're feeling. Now, as we move to multiplication, lots of different ways that we can help students with their multiplication computation. So we have the traditional algorithm, or you might call that the standard algorithm. Probably that's how many of you learned to multiply in school. That's certainly the case for me. But we can also multiply in different ways. We could think about using this partial products algorithm. Some of you might be interested in the lattice method of multiplication. And the one we'll focus on today is the array model, or the array method, or we might call it the area model. And this is really just a different arrangement of partial products. So let's see what that might look like if I'm solving this problem, 63 times 21. Well, first I'm going to create an array that represents the digits in each factor. So here I'm multiplying a 2-digit number times another 2-digit number. So that means I need to make an array that has 2 columns and 2 rows. And then I'm going to write that first factor here, that's 63. I'm going to write that in expanded form. And so that would be 60 and 3. And then I'll multiply that by my second factor. So I need to write that in expanded form, which ends up being 20 and 1. So now that we have this set up, we are going to multiply 60 times 20, 3 times 20, 60 times 1, and 3 times 1. Those numbers that are in orange, those are my partial products. So let's go ahead and add those partial products together to figure out the final product, which in this problem is 1,323. I really like this strategy. It just provides some organization to the partial product strategy that might be difficult for students, particularly if students have difficulty lining up place values, such as that student that we saw earlier with that word problem example where they had misaligned their place values and so they answered the problem incorrectly. Let's not have that happen here. We can use our array to really help us be more organizational with our work. So it's your opportunity to practice this. I'm going to come back to that in a minute with number 3 on your printable. So go ahead and look at 59 times 13. What would that look like using the array or area model? Give it a try, and I'll see you in a minute. All right, that's just about a minute of work time there. As we look at this response, we can see that if I multiply those numbers together, I come up with a product of 767. Now, this array model is something that we see a lot on the STAR. So here is an example from the STAR from fourth grade from last year, where students are asked to think about multiplication as an array. And so they're setting up that array and they have to write those two factors in expanded form. So if students had practice with this array or area model, they would likely be able to answer this problem here correctly. So tell us how you're feeling about this array method or this area model. And then as we move to division, we have our traditional algorithm, which is a good one to rely on. But we can also use the partial quotients strategy or the lattice method. We can do that. And all of these, we can use different manipulatives to help the students understand what the division actually means. Today in Spiral, we will focus on this partial quotients strategy. So here I'm going to first draw a vertical line down from the end of my long division bracket. And then I'm going to think about dividing this 580 by 10 or dividing the dividend by the divisor. So I ask myself, how many groups of 10 can I make if I have 580? Well, that answer might be obvious to some, but not obvious to others. So let's try to break this problem down into parts. So I might say, well, I'm not exactly sure how many groups of 10 I can make with 580, but I know that 10 times 50 is 500. So I'll go ahead and write that right there. And then I'll subtract 580, the 580 minus 500. That gives me a remainder here of 80. Then I ask myself, well, how many groups of 10 can I make if I have 80? Well, I can make 8 groups of 10. 10 times 8 is 80. I subtract, and then I have 0 remaining, so I'm not going to do any more division. But over there on the right-hand side of the problem in gray, there I have my partial quotients. And if I add those together, that gives me a quotient of 58. So when I have 580 divided by 10, my quotient is 58. So you give it a try. What would it look like to have 670 divided by 10? Kind of a simple problem there, but I think it's always a good one to start with if you haven't used the strategy before. But if you have, make yourself a more complicated problem. But go ahead and try number 4 on your printable. If you are going to use manipulatives, either hands-on or virtual manipulatives, or if you're going to use drawings for these division and multiplication problems, make sure you're doing, I would say, simpler problems here. We typically don't want students to be using manipulatives for problems where it involves hundreds or thousands or 10,000s. It just doesn't make sense. But maybe you do a smaller part of the problem to help students understand the division, and then you can go on to more complicated problems such as this. So here, if I was solving this problem, I might have figured out I could use those partial quotients of 60 and 7 to figure out a final quotient of 67. So tell us about how you're feeling with those partial quotients today. Are you a 1? Are you a 2? Or are you a 3?
Okay, so I have created 2 resources for y'all that are online and in your educator notebooks. The first of which is the Multiplication and Division Intervention Tracker. And so it starts out with almost phases of multiplication and division that are aligned with our fourth and fifth grade Texas standards. So phases A through I are aligned with our fourth grade standards, and they begin with multiplying 1-digit by 1-digit numbers, then dividing 1-digit by 1-digit numbers. Then it builds multiplying 1-digit by 2-digit, dividing 2-digit by 2-digit, and so on until we get to phases J and K that align with our fifth grade standards of dividing 4-digit numbers by 2-digit numbers and multiplying 2-digit numbers by 3-digit numbers. And then phase L, we have spiral review. And so the way that I've used this resource in the past, and when I taught second grade, I was using the addition and subtraction version. But nonetheless, what I would do is I would have all of my students who needed computation intervention come to my back table in small groups. And they could be in any combination of students, even if their skill levels were different from one another. All they would need is a math notebook and a pencil, and I would have a tracker for each of them that I kept track of. And so what I would do is one at a time, I would glance at each student's tracker to figure out what phase or what level of computation are they currently proficient in, and what level up do they need practice or intervention with. And so I could glance at maybe my 4 students that are in my small groups trackers and know what types of problems to generate for each of them. And so I would jot down a problem for one student, hand it off to them, they'd start solving, I'd get the next student solving, and so on. And so it was zero prep. All students needed were notebooks and pencils. I needed my trackers, and in small groups, each student had tailored computation practice and intervention from me. And so after those phases are broken down for you, you have a spot to record all of your intervention sessions with that student. Maybe it's one-on-one, maybe it's in a small group. You can record the date. You can record the length of time that you met with them. You can put the focus or that phase of skill level that they're currently in. And then you can write notes so that you can prepare for your next intervention session with them. Maybe you know that in the next session, you want to break something down with base 10 blocks. And so you can jot down a note. In this example, this student was working on dividing 3-digit numbers by 1-digit numbers. And in the notes, it says that they solved 3 problems accurately in a row. And so maybe you would check off level F for this student, and then the following day, have them try, explicitly teach them, have them practice multiplying 1-digit numbers by 3-digit numbers. And so you see, I alternated between multiplication and division because we don't want students to spend so much time multiplying that they lose their proficiency with division and so on. It's good to alternate so that students' skills stay fresh and you can easily incorporate the reciprocal nature of multiplication and division in this way. You also have an addition and subtraction whole number computation intervention tracker. And this is for these students that still need intervention with addition and subtraction within 1,000. And so this tracker starts with single digit addition without regrouping, single digit subtraction without regrouping, and then it builds until we have, subtraction across zeros, addition and subtraction with 2 and 3-digit numbers with and without regrouping. And so what you can do is your students who you know need intervention with multiplication and division or with addition and subtraction, you can pull them one-on-one and then have them start solving a few problems at the phase that you think they are relatively proficient at, and then keep going with them until they start to make errors, and then record that because that is the phase that they need some explicit instruction and some further intervention in working on. And then once you know where each of those students are performing at, you can group them if you'd like to, if you have students that are in similar areas with their skills, or you can just pull them in mixed groups, glance at their trackers, and provide each of them with tailored problems based on their needs. And so if you haven't already implemented these trackers in your classrooms yet, I hope that you will moving forward. I've also created a video that goes really in depth on how to use these resources. It's on the website now, but I will email it to y'all at the end of this week. All right, so we have made it to our exit ticket. We have 3 questions that relate to feedback on this professional learning. And then we have some questions where you'll be providing your coach with information. And so when you get to question 4, you are going to pick a focus area for this next coaching cycle. You are going to choose error analysis, fact fluency, or computation fluency. And then when you get to question 6, you are going to think about what is one way that you will collect student data related to your focus. So if you chose error analysis, maybe you will do some formative and summative assessments and analyze the errors and go from there. Maybe if you want to focus on fact fluency, you will implement the flashcard graphing that Kate covered in that video. And if you choose to focus on computation fluency, maybe you will implement the computation intervention trackers.